Right, ladies and gentlemen. So following on from what you've just done, this was like the washing machine, and at one end was the impossible, the other end was certain. This is expressing probability in terms of words, vocabulary, but we want to be able to fill in the gaps a little bit, but also do it with numbers. So, what goes in between impossible and certain? Give me some numbers and some words and where they would go. Dash. So where is that? That's certain. That's certain. So right in the middle, you would say even. Numerically. Using numbers, basically. Yes.
May.
All right, so that's a bit of a weird one. We don't use it. I know it was on the computer screen. Something may or might happen. Isn't. How would you describe that in terms of probability? Probable or not probable?
I'll have another one.
Oh, well, let's do may first. Bo? It
maybe
may
probable,
happen. It
'cause,
might.
like,
Pardon?
You might trip or something.
So what would you say? Is that unlikely to happen? If you say it might happen, what would you be saying? Like, England might win the World Cup.
Like you're not very sure, but it's kind of more like it's a guess. Well, like you're not really sure.
So could that be a low probability? Okay. What do you reckon, Brooklyn? Yeah. Because let's put it in a way you might appreciate. If you say to me, "Oh, Mr. Potts, do you think I'll get a good score in my test?" And I go, "Might happen." Would you think that was a positive or a slightly negative answer to you? You'd be like, "Oh, you're basically saying I'm going to fail." But I go, "You might pass." If I said, "Oh yeah, probably," you'd be like, "Oh, probably." But if I went, "You might," it's a bit. So actually,
Yeah.
you might pass.
You might pass.
I still think probably means good. Might. It might. Dan is. So we're going to leave out the word might, but you've got a good on it. So this end would be more along the unlikely. So if we can put the unlikely side here, and this side would be likely. All right? And basically fill in the gap would be very unlikely and very likely. All right? And we do have some other words depending on, might, may, could, and, and that's what that washing line thing was about, showing you we do have lots of words for anyway. Now, the thing is, those words are great. What's the chance of getting a king from a pack of cards when we played our game? Well, why are you going straight to numbers? Why don't you say it's... Is it?
How many things there are?
4 kings, 52 cards.
Four things. If each card with the.
So it's quite unlikely. That's the whole point of cards. Now, but do you realise what you did was you started going to the numbers. Not 13. There are 4. Alright, well let's look at that. Actually, I wasn't going to jump straight to there. I'm going to give you some vocabulary. Look, the probability of getting a king. Now, guys, that is the way, using notation, you can write this down. What this means is the P for probability of selecting a king from a pack of cards is, all right, so we would say there are 4 kings in a pack of 52 cards. 4 from 52 can be simplified to 1 from 13. What percentage is that? How do we work it out? How do you turn a fraction into a percentage? I know you've done it because I'm doing it with my M1s currently. What did you do? So he did 1 divided by 13, because that's what this says, isn't it? 1 divided by 13. And then you times that by 100, and there's a reason for that, hopefully you remember, and you get 7.69% rounded. So, unlikely or likely? Unlikely, right? So that was a little bit ahead of schedule, but we've got an idea, right? I'll let you write that. So there's a couple of important things there. The first one really is this notation, the probability, all right? If you remember doing the cards last year, my group, we did it this year, didn't we? Once? The follow me cards? They're not those things. I am, we haven't done it yet. The smaller card. Oh, we got donuts last year, didn't we? Yeah, I am. Right, so we had that probability of king, that's notation, so that appears in those cards, but now you know. And then it's how we write the fraction and then how we convert it to a percentage. Now, what's important is we know about this numerical thing and how it relates to the words. Because in future, what we're going to do is we're going to calculate the probabilities using numbers, using fractions. We can convert to percentages if we like, but we do need to understand what that means, whether it's likely or unlikely. Now let's just finish this diagram off. So, what does it mean to have impossible probability? It would mean 0. Certain is, you've already told me, 100%, or as a decimal is 1. Now, you already started telling me about fractions. What's the problem with me writing a fraction for 1? How many fractions are equivalent to 1? A bunch. It would be
Every number?
every number, yeah? 2 out of 2, 3 out of 3, 4 out of 4, 5 out of 5, 6 out of 6, 52 out of 52, yeah? So we can't really put one fraction on our number line. And that's the trouble with going in between here as well. We have to understand where the number would fall on the number line when we work it out. But we know that impossible is 0, or 0 out of anything you like. Yeah, you get 0. And 100% would be 100 out of 100, 10 out of 10, 20 out of 20, a million out of a million. So, what about even? That would be a 50% chance. Does that explain to you why sometimes even chance is called 50-50? Because you've got a 50 chance of failing and a 50 chance of passing, yeah, succeeding. So 50-50 is 50 of each chance. It's the same, basically. How would that look like as a fraction? 1 out of 2, 50 out of 100, and so on. Yeah? So anything that's equivalent to a half, basically. Okay? So what would be some other examples that would fall in here? Now, we've already got that this one, 1/13, is unlikely. Where would you put that? I'm going to start here and I'm going to go across. Tell me when to stop. Do you think? Do you think that's approximately less than 8%? That's almost 25. So 25% would be here. Yeah, which would be 1/4. What would be here?
1.
So 75%, which would be anything 3/4. So where would this one be? More like here, yeah? So 1/13 maybe. Now that would mean 13 would have to be, I've maybe done it a bit small, but maybe a little bit further. I'm going to put it a little bit further on. Maybe 1/13, which is, actually I should be consistent. So that would be 7.69%, which would be 1/13. I'm going to ask you to put 3 more along your number line. Just find a percentage and find a fraction if you can. And then I'm going to ask you to give me what you wrote. Up to you. Discuss it with each other if you like, but try and put in 3 more. Basically, one of the most important things that you have to do in probability is get the fraction right. Okay, so to your notes, what does the fraction represent? Okay, so what we've got, the probability fraction, we say the probability of an event happening is a fraction where we fill this box and we divide by whatever's in this box. Okay, so we've got the numerator and the denominator. Okay, now we've got to figure out what those two numbers are. What's in there? This one, everyone normally finds easy. This one, quite often there are mistakes. Okay? All right. It is super important that we get those numbers correct. Obviously, if we get them wrong, we've got the wrong probability, right? Okay. And the mistakes normally happen with the denominator. So does anyone know what these two numbers represent? So the numerator and the denominator of the fraction. You know these words, yeah? You've met them before? Yeah? Does anyone in probability know what the denominator represents? Well, let's take the probability of getting a king in a pack of cards. It's 4 from 52. So what does the 52 mean?
How much cards is in there? How much cards there?
How many cards there are in total here. So the denominator is what we've got in this vocab, important vocab here, is the total number of possible outcomes. So in this case, 52, because there are 52 possible cards I could take. Yeah? That makes sense? Now, it's not always going to be cards, is it? If I was rolling a die, for instance, how many possible outcomes are there? 6. All right? If I were looking at the probability of getting a boy from this classroom, well, it would be out of how many students are in the room. Yeah? So it would be the total, now the total possible outcomes people make, do you understand where the mistakes come from? Because if I said, what's the probability of getting a boy, people will go, oh, well, there's boys and girls. Therefore, it's 1 out of 2. Because boy is 1 and there are 2 boys and girls, but it's not that. It's the probability the event is me getting a person that is a boy. So the possible number of outcomes is every person, right? And in this case, the denominator would be the number of cards. Now it's important that I get this number right, because if I get that wrong, it massively impacts my probability. So if this is the total number of possible outcomes, the numerator is the number of ways of getting the outcome I want. So in a pack of cards, how many ways are there of me getting a king? 4. I have 4 chances of getting a king. But there are 52 possible outcomes. All right, so 4 from 52. And that's what probability fractions are. So we start by writing fractions. That's why probability in fractions is the easiest thing to work. All right, go on. Well, we've already shown it's not, no? What is it? Well, we said 7.69%. Right? Because we can convert fraction into a percentage, can't we? Right? But it's super easy to write the fraction first. All right? That makes sense. So, what you are going to be looking at is the following thing. So, when I set you some work, I'll get you to look at it today, just quickly before lunchtime. But this is what you're going to be looking at for the next lesson, which is tomorrow? Yeah. All right. So, how do I figure out the total number of outcomes? You writing this down? And this is another piece of vocabulary for you, so I hope you're writing it all down. I use a sample space diagram. It's got nothing to do with stars and spaceships and things like that. It's just a space, a sample space diagram. Now there are different versions of a sample space diagram. Okay? A sample space could just be a list of possible outcomes. A sample space could be a table. A sample space could be a tree diagram. Okay? So it's just a fancy way of saying write down all the possible outcomes. So, how are you doing with the writing? You good?
Yeah.
Should I pause for a second?
No.
Everyone good? Yeah. Okay. Let me give you an example then. So, write out the sample space for rolling a die once. Using a list, right? It could be a 1, a 2, 3, a 4, a 5, and a 6. Done. That's it. No, I haven't asked for an event. I just want to know what are all the possible outcomes. So now I know that there are 6 possible outcomes. So what that tells me is that in my denominator, in my fraction, this I don't know yet, but this number is a 6. And I can always write a 6. Sometimes I can simplify it, but I know it's a 6. I'm going to go straight to a harder one. but you'll end up getting some easier stuff back in class. Okay, when you do the book.
Can I use one other page to write? Or?
Yeah, you can do. Write the sample space for rolling 2 dice. Use a table. So this time, all right, excuse me while I look in the direction I can actually see. I am going to use what we call a two-way table, and that's because dice 1, I could get a 1, a 2, a 3, a 4, a 5, and a 6. And dice 2, I could get a 1, a 2, a 3, 4, 5, and a 6. So what are all the possible outcomes? Oh. What are all the possible outcomes for rolling 2 dice? I could get a 1 and a 1, a 1 and a 2, a 1 and a 3, and so on, yeah? Here it would be a 4 and a 4. This one would be a 6 and a 2. This one would be a 2 and a 6. So, in this case, this number would be a question mark. This number would be 36. Right? There are 36 possible outcomes. And this here, this is the sample space. Just listing all the possible outcomes. All right? No, so I haven't given you an event yet. All right? So now, for instance, if I said, what's the probability of getting a double? So what would a double mean? Yeah. So now I could say 1 and 1, 2 and 2, 3 and 3, 4 and 4, 5 and 5, 6 and 6. So it would be 6 from 36. Because I know there are 36 possible outcomes. Now, why do people make a mistake with this number again? Well, they go, well, 6 and 2 is the same as 2 and 6. But it's not. Yeah, because there are 2 ways of getting that same result. So it has to be written twice. There is only one way of getting 1 and 1. But it's more likely to get 2 and 6 than it is 1 and 1. Yeah, because there are 2 ways of getting it. All right. Before we have lunch, you are going to be, story of this book's life at the moment. All right, are you ready for this? This is going to be on the video. You are going to be looking at practice 1. Right, so we're looking at, you can have a look at these examples and things. All right, but when I set you tomorrow's work, because I won't be here, practice 1, can you write this in your book now, in the next available space? Practice 1, page 52, list all the possible outcomes. You know, for these events, that's why I went through the vocabulary. Look, outcomes, events, you know, what could happen if I toss a coin? And that's it. Not 50-50. What could happen? Heads or tails. That's it. That's all I want for that question. 6-sided die. What could happen? 1, 2, yeah. A 6 classes are chosen for a year 2 student by a counsellor. Well, that's a different one. So that's like, what lessons could you choose? English, maths, French, Spanish. Yeah. The answer in the back of the book is not going to be relevant to you, but a date is chosen in February.
So
The first, the second, 20th. Now, it's not asking you, here's the important thing, so I'm recording it if you need to review. This question is not asking you for any probabilities, it's only asking you how many possible outcomes there are to get the number for the denominator. All right? Then it starts going into, all right, how many possible, this is a good question, all right? Nice, big, long question there. Right, you've got plenty of work to do. All right, that's for at least tomorrow, maybe 2 lessons. And then if you're good, we've already gone into probability numerically. You can probably already do this as well, right? Those of you that want some homework, all right, we've already done this, so you could get on with it. All the way, right in your book, please. All the way up to the end of, so page 58. You can get to that end of that one. So you've got work to do, and I can tell you're a cover teacher, and it's on the video.